Okey, saya rasa kita boleh mulakan sudah sesi kita. Sebab sudah lepas 5 minit. So, Assalamualaikum and good morning everyone. I hope that you guys are doing well and healthy. And first of all, I would like to say thank you to the management of the faculty for organizing this workshop, if we can call it a workshop. And thank you very much everyone for joining the session. I hope that we can get a fruitful discussion from the workshop. And since we have a number of international students, so we will try to conduct the session in English, but of course I will what you call as try to translate some terms in Bahasa Malaysia as well to make it easy for everyone to understand, so that we can maximize our understanding on our discussion. And I hope that you guys can hear my voice. I hope that the audio is okay. So as an introduction, this workshop, in this seminar or workshop, we will try to discuss the introduction to quantitative analysis, where our focus will be towards secondary data, since we have the term introduction here. So I will try to use terminology that most of us can understand, because we have participants from various backgrounds, from PhD students, master degree as well as bachelor degree. So I will try my best in order to use terms that are user-friendly, terms that every one of us can understand. And since we are focusing towards, or since we are discussing the quantitative analysis, I will also try to do some basic tutorial on how to process the secondary data quantitative analysis, or in other words, I will try to show you how to process quantitative secondary data. There are a number of objectives. There are a number of objectives that we will try to meet based on this session. Basically, there are 4 learning outcomes or objectives that we will try to meet. First, we will try to discuss the difference between primary and secondary data. So kita akan cuba untuk membincangkan perbezaan di antara data primer dan juga data sekunder. And then after that, we will discuss the difference between quantitative and qualitative variable, because this is one of what we can consider as confusions that frequently happen among the students, where they fail to distinguish or differentiate the difference between quantitative and qualitative variable, that resulted to the failure of choosing or conducting a correct analysis towards the data that they have. So kita akan cuba juga untuk membincangkan secara ringkas perbezaan di antara pembeli ubah kualitatif dan juga pembeli ubah kuantitatif. And then after that, we will move into the third objectives of our discussion, that is to discuss the different types of data set. And there are basically 3 types of data sets. They are the cross-sectional, time series, as well as panel data sets. So it is important for us to briefly discuss these basic terminologies, or these basic concepts, the basic concepts of data and variable, so that it is more easy and convenient for us to discuss the main topic of discussion, that is to analyze secondary data quantitative analysis, or to quantitatively analyze secondary data. And in this case, in this workshop, we will be using free statistical software known as Gretel. So the reason why I'm choosing Gretel instead of various statistical software out there is because Gradle is free. So everyone can download from the internet and everyone can use it rather than, you know, using a pirated copy of eViews, Stata, and any other statistical software. So we move into the first discussion, move into our first discussion, that is distinguishing the difference between primary and secondary data. So the difference between primary and secondary data is in terms of how we collect the data, in terms of how we collect the data. So that is the difference between primary and secondary data. A primary data is a type of data that is collected by a researcher first-hand from the original source. So maksudnya, data primer adalah data yang dikutip oleh pengkaji ataupun penyelidik daripada sumber yang asal tanpa ada intermediaries, tanpa ada perantara. So there are various methods that we can use to collect primary data, and of course the most famous is through surveys and interviews. But some of the research out there also requires experiment to be conducted in order to collect primary data. So primary data, as you can read from the slide, is collected with the research project in mind, directly from primary sources. So secondary data, on the other hand, is gathered from previous studies, or they can also be gathered from the database if the database is available. So secondary data has an intermediaries between the researcher and the original source. So these intermediaries can be different studies, or they can also be the various database that we can use. And the database, they can be free, but some of them you have to pay them as well in order to use or to gather the data that they have. So the data, secondary data, have been run by other people or from other research as well. But of course, our main focus will be towards secondary data, where we will try to discuss how to process data that we gathered from either previous studies or the data that we gathered from database. Another important concept that we need to understand as well will be the quantitative and qualitative variable. So a variable, as you can read, is the general characteristic being observed on a subject. So a subject can be anyone. It can be anything that we observe the attributes from. For example, say that we wanted to analyze the CGPA of all students in UMS. So the subject will be these students, while the attributes that we observe is the CGPA. So pemboleh upah kita boleh tafsirkan sebagai satu bentuk kriteria, satu bentuk kriteria yang dikaji pada sesuatu subjek. Subjek itu boleh jadi apa sekalipun. Subjek itu boleh menjadi apa sekalipun sumber bagi attributes yang kita ingin kaji. Sebagai contohnya, katakan kita ingin mengkaji CGPA bagi pelajar. So subjek kita adalah pelajar, dan CGPA itu pula adalah attributes yang kita ingin kaji, sifat ataupun maklumat yang kita ingin perolehi. So there are two basic types of variables. They are the qualitative and quantitative variables. And in order to distinguish between qualitative and quantitative variable, you have to look into what we call as scale of measurement used to measure the data. So terdapat satu perbezaan di antara kualitatif dan kuantitatif variable, atau pembuluh ubah kualitatif dan pembuluh ubah kuantitatif. Dan perbezaan ini adalah merujuk kepada skala pengukuran yang digunakan untuk mengukur data kita. And there are 4 types of scale of measurement. Scale of measurement is used to characterize the attributes of a subject. Skala pengukuran digunakan untuk mengkategorikan attribute bagi subjek yang dikaji. So the most basic scale of measurement is called nominal scale of measurement. So in a nominal scales of measurement, the data is characterized based on labels or names. For example, if we characterize the student based on the faculty where they belong, some of the students can be from FPEP, some of the students can be from FPEP, some of the other students can be from FKJ. So differentiating or characterizing students based on the faculty that they belong can be considered as using nominal scales of measurement, because we simply characterize, we simply differentiate one student to the rest based on their faculty. So skala pengukuran nominal membezakan ataupun memberi karakteristik kepada data berdasarkan label dan nama sahaja. Another scales of measurement is called ordinal scales of measurement. So ordinal scales of measurement is a type of nominal scales of measurement. But in a nominal scales of measurement, the data is characterized based on labels and names, and these labels or names can be ranked. So that is the difference between nominal and ordinal scales of measurement. In non-ordinal scales of measurement, these labels can be ranked. For example, say that we rank student based on their seniority. So some of these students can be freshmen, some of these students can be junior, some of them can be senior. So we know that senior student is much older, much more senior than the junior as well as the freshman. So skala pengukuran ordinal adalah satu bentuk skala pengukuran nominal. Tetapi perbezaan bagi skala pengukuran nominal dan ordinal adalah, bagi skala pengukuran ordinal, data dibezakan berdasarkan label yang boleh disusun mengikut ranking. Okay, tadi jika kita merujuk kepada faculty, we cannot rank this faculty. We cannot say that FPEP is higher or more superior than FPP, for example. We cannot say that. We can simply label them. But on the other hand, the ordinal scale can rank these labels. For example, based on their seniority, just like I mentioned just now. So if you're using data that uses nominal and ordinal scale of measurement, that means you are analyzing a qualitative variables. Okay? You are analyzing a qualitative variables. And the third scales of measurement is called interval scale of measurement. Interval scale of measurement. So in an interval scales of measurement, these rank can be measured. Okay, interval scales of measurement is similar to the ordinal scales of measurement, but the difference between ordinal and interval is that for an interval scales of measurement, these characteristics, these ranks or these label, apart from you can rank them, but you can also measure the difference between the rank. In other words, the rank is meaningful. Meaningful means you can subtract or add the differences between the rank. Okay, for example, say that we analyzes the temperature. So if we wanted to analyze the temperature, we may use Fahrenheit. We can also use Celsius, degrees. So degree Celsius is a type of interval scale of measurement because we have rank. We have 20 degrees, we have 21 degrees, we have 22 degrees, we have 30 degrees. These are ranked. And apart from that, the difference between these ranks are meaningful. In other words, we know that the difference between 30 Celsius degree and 20 Celsius degree is 10 Celsius degree. So you can add or subtract these ranks. Okay? You can add or subtract these two ranks, for example, and they are meaningful. And the last scale of measurement is called ratio scale of measurement. So ratio scale of measurement is a type of interval scales of measurement. But the difference between interval and ratio scale of measurement is that in a ratio scale of measurement, we have an absolute zero. Okay, we have an absolute zero. Terdapat perbezaan di antara skala pengukuran nisbah dan skala pengukuran selang. Interval is selang, ratio means nisbah. Untuk skala pengukuran nisbah, kita ada konsep ataupun terma yang kita panggil sebagai sifar mutlak, where we have zero as an absolute zero. For example, our height and our weight. If our weight is 30 kilogram, we know that we have some sort of weight. But if our weight is zero, we know that we don't have any weight at all. We don't have any mass. So that is the difference between interval and ratio scales of measurement. So if you're using data where these data uses interval and ratio scale of measurement, that means you are analyzing a quantitative data variable. You are analyzing a quantitative variables. So amat penting untuk kita memahami perbezaan di antara data kualitatif dan juga data kuantitatif. Kerana setiap pembuli ubah ini menggunakan kaedah analisis yang berbeza. And of course, our focus will be towards quantitative data analysis. And of course, it is important for us to explain these terminologies as well. For example, the difference between primary, the difference between variables, so that our participants, particularly from bachelor degree, can understand and follow our discussion. So, as I mentioned before this, if you are using a qualitative, that means the scales of measurement that you use will be nominal and ordinal. And of course, qualitative can be both numerical or non-numerical. While if you are using or analyzing quantitative data analysis, that means you are analyzing the interval scales. You are using the interval scales of measurement in order to characterize the attributes that you study from a subject. And the third objective is the types of data. So if you have any question, you can just you can just let me know either through the chat or perhaps, oh, I forgot. I think I forgot to show you the windows, unfortunately. Yeah. I think I forgot to show you the windows. So this is what I'm talking about. This is what I'm talking about. Yeah. Sorry for that one. Yeah, I forgot to inform you guys. I forgot to show you the slides. Sorry for that one. I thought that I already shared the slides, but it's okay. Okay. So, yeah. This is the learning objective. Of course, don't have to be worried. We're not going to repeat the discussion. I'm just going to show you what I am talking about. Yeah. So we have 4 objectives. First is to discuss the source of our data. Second is to discuss the types of variable. Third is to discuss the types of data. And then fourth is to discuss the quantitative secondary data analysis. And as I mentioned before this, we have 2 sources of data. They can be primary and they can also be secondary. They can be primary. Primary is a type of data that we collect from the original source. There are a few methods that we use to collect primary data: survey, interviews, or experiment. And for secondary data, on the other hand, we have intermediaries. We can call these concept as intermediaries. So we have intermediaries between the researcher, and the original source. So in a secondary data, we basically gather the data from previous studies, or we can also collect the data based on database. Okay, we can either collect from previous studies, or we can also collect from from the available database. And this is what I'm talking about just now, the types of variables. So we have qualitative and quantitative variables. So if you have any question, you can just open your microphone and ask, because at the moment I cannot see any chat. So you can just feel free to interrupt and ask your question, so that we can have a sort of discussion from the first until the last objectives. It will be fruitful that way. So yeah, as I mentioned just now, if you have data that uses nominal and ordinal scales of measurement, that means you are analyzing a qualitative variable. On the other hand, if you have data that uses interval and ratio scale of measurement, that means you are analyzing a quantitative variable. So among the types of qualitative variable will be the gender, race, as well as political affiliation. While among the types of quantitative variable will be test scores, age, and weight. As I mentioned just now, nominal scales of measurement characterize the attributes of a subject simply based on labels and names. For example, FPEP, FCAL, FPP, and so on. On the other hand, ordinal scales of measurement characterize the attributes based on labels that can be ranked. For example, seniority. Okay, for example, seniority. And interval scales of measurement, on the other hand, characterize the attributes based on rank that can be measured. In other words, these ranks, the difference between these ranks are meaningful. You can add, you can subtract them as well. So jika kita ada data yang mana karakteristik bagi sesuatu data itu boleh diukur, okay, boleh diukur, that means ini bermakna kita menggunakan skala pengukuran selang. For example, Fahrenheit, as I mentioned just now, or Celsius degree is another type of data that uses interval scales of measurement. And last but not least, the final or the most complex, if you can call it complex scale of measurement, is the ratio scale of measurement. So in a ratio scale of measurement, we, apart from ranking and the difference between this rank are meaningful, but you also have a term called as absolute zero. Okay, so perbezaan di antara interval and ratio scale of measurement is that in a ratio scale of measurement you have an absolute zero. For example, your age, it cannot exceed zero. Your weight, it cannot be negative. So you cannot have a negative values in a ratio scale of measurement. You have an absolute zero. Zero means zero. Okay. So seperti yang saya sebutkan, as I mentioned just now, so in a qualitative data variables, you have ordinal and nominal scales. In a quantitative data variable, you have interval and ratio scale of measurement. So the third objective is to analyze or discuss the various types of data. And basically, there are three types of data. They are cross-sectional, time series, and panel data. Okay, so we are focusing towards quantitative analysis now. Okay, we are shifting our attention towards quantitative data analysis. And when we are talking about quantitative data analysis, basically there are three types of data. They are the cross-sectional, time series, and panel data. So a cross-sectional data is a type of data set where the data is collected by recording the attributes of many subjects at the same point in time without regard to differences in time. In other words, in a cross-sectional data, you have various or multiple subjects, but only one point of time. So maksudnya data keratan rentas merujuk kepada data di mana kita mempunyai pelbagai subjek. Subject can be anything, as I mentioned before this. They can be students, they can be institution. They are the source of your information. And in a cross-sectional data, you only have one point of time. Okay. For example, the CGPA for all UMS students in semester 1, session 2019-2020. So you have multiple subjects. In this case, it refers to the UMS students, all UMS students. They can be thousands of subjects. At one point in time. In this case, our point of time is semester 1, session 2019-2020. Another type of data is the time series data. So if a cross-sectional data refers to the type of data that you collect from various subjects at one point in time, time series data, on the other hand, is a type of data set that you collect by recording the characteristic of a subject, one subject only, over several time period. So you only have one subject, but multiple time periods. So these time periods can be in various what we call as frequencies. So they can be hourly, they can be daily, they can be weekly, monthly, quarterly, or annual observation. So dalam data siri masa, kita mempunyai satu subjek yang tunggal, tetapi pelbagai tempoh masa. Tempoh masa ini boleh jadi dalam beberapa bentuk frekuensi, dalam jam, hari, minggu, bulan, ataupun tahunan dan juga sukuan. Contohnya, for example, the CGPA of one UMS student from semester 1, session 2019-2020 to semester 2, session 2021-2022. So, before this, we have all UMS students, one semester. Now, in a time series data, you only have one student for various or multiple semesters. And the third type of data is panel data. So panel data is the what you call as a combination between time series and cross-sectional data. So data panel adalah satu bentuk data set yang merupakan gabungan di antara data siri masa dan juga data keratan rentas. Okay, in a panel data analysis, you have multiple subjects over multiple time periods. You have multiple subjects over multiple time periods. For example, the CGPA for all UMS students from the first semester until the semester that they completed their study. So panel data is also called as longitudinal data. So kita panggil data panel sebagai data longitudinal juga. So our focus in this what you call as a workshop will be towards time series and panel data. So hopefully that we have sufficient time to discuss these two types of data set, and we are not going to focus into the cross-sectional data, number one, because not many of us are using cross-sectional data, especially I am referring to us in this what you call as a session. And secondly, sometimes we can also use the methods of time series data in order to analyze cross-sectional data. Not all of the time, but sometimes you can also use methods of analyzing time series data in order to analyze cross-sectional data set. So moving towards the key discussion, we are moving towards the key discussion for our workshop. In this, what we call as a section, we are going to discuss how we are going to analyze the relationship between variables. Basically, we have two types of variables. They are dependent and independent variables. I'm referring to a secondary quantitative data. Basically, we have two types of variables. They are the dependent and independent variables. So independent variables are the types of variables that we wanted to study. We wanted to study whether these variables can influence the dependent variables. So secara umumnya terdapat dua jenis pembeli ubah bebas dan juga pembeli ubah bersandar. Pembeli ubah bersandar merujuk kepada dependent variable dan pembeli ubah bebas merujuk kepada pembeli ubah yang mempengaruhi pembeli ubah bersandar tadi. And as I mentioned just now, we are going to focus towards time series data analysis as well as panel data analysis. So these are the two types of analysis that we are going to focus on. So in here we have an econometric model, a simple time series model. Okay, we have a simple time series model where we have the two variables, the two types of variables. Here on the left-hand side of the equation, we have y representing the dependent variable, and on the right-hand side of the equations, we have a set of independent variable. We know that this is a set of independent variable because we have this, what you call as a symbol over here, that represent a set of independent variable. Satu set pembeli ubah bebas. So pembeli ubah bebas ini boleh jadi pelbagai. They can be multiple. Okay? They can be multiple. They can also be a single independent variable. So this beta, on the other hand, represent the parameters in the model. So these beta are the coefficients that we wanted to analyze the value. Okay, so our job in a time series data analysis is to basically measure the value of these two coefficients. Okay, we wanted to analyze the value of these two coefficients, and we also wanted to analyze the sign of the coefficients. That are the two main focus in a time series analysis. Dalam analisis data siri masa, fokus kita adalah kepada dua. Okay, of course, terdapat pelbagai fokus yang lain bergantung kepada objektif kajian. Tetapi dua fokus yang utama adalah dalam menentukan sign ataupun petunjuk bagi pekali ataupun koefisien dan juga menentukan nilai bagi pekali tersebut. Okay, to determine the sign of the coefficient and identify the value of the coefficient of these two coefficients. This coefficient represents the intercept. Okay, these represent the intercept. Intercept means the value of y when x is equal to 0. So that is the most basic way to interpret what an intercept is. So intercept is pemintas. Okay, ini adalah pintasan, nilai pintasan. Nilai pintasan merujuk kepada nilai y apabila x bersamaan dengan sifar. And in the right hand side of the equation, you have this last term known as the residuals or the error term. Okay, the residuals or the error term. Any types of value that is collected outside of the x, okay, merujuk kepada nilai yang berada di luar pembeli ubah bebas yang mampu mempengaruhi pembeli ubah bersandar. Okay, that is basically how we can briefly interpret the error term. Of course, as I mentioned before this in the earliest part of our discussion, I will try to use the most simplest terminology so that all of us can understand what we are trying to discuss, what I'm trying to say. So when we are talking about time series data, before that, let me stop sharing the slides because I wanted to see if there is any question. I'm not really familiar with what you call as Google Meet, so I'm trying to see if we have any questions. Because before this, we have a situation. That is, I forgot to post the slides, the presentation slides. All right, so let me show the slides again. So jika kawan-kawan ada sebarang soalan, kawan-kawan boleh post. Kawan-kawan boleh sahaja tanya melalui butang audio dalam bahasa Malaysia. Okay, there is no problem with that. Okay, I will try to entertain as many question as possible. Kita akan cuba untuk menjawab sebanyak mungkin soalan. Okay, berdasarkan kepada tempoh masa yang diberikan. Alright, so I hope that you guys can see this slide. So ini adalah slide yang saya buat baru-baru ini. Sebenarnya saya ada satu slide, ada satu what you call as carta alir, if we can call it flow chart. There is a very good flow chart that I used to refer to when I was doing my PhD. But unfortunately, when I tried to retrieve the what you call as that chart flow from the internet, I was unable to retrieve it. So that is why I have to create a somewhat similar to that one. But that one is much better. So if you can, if you have time, you can simply you can simply Google flowchart for time series data analysis. Who knows that you might be able to identify the chart, which is very useful. But don't worry, this is very useful, particularly in our topic of discussion. So in this chart, we have flows that we have to go through in order to process our time series data. So carta ini, gambar raja ini, this figure menunjukkan proses yang kita perlu lalui untuk memproses data bagi menghasilkan maklumat yang berguna. Remember, we are trying to process a time series data in order to obtain useful information. So these are the steps. So these are the process that we have to go through. Of course, in real life, there are various types of analysis that you can apply in order to analyze time series data. But we are going to focus into these types of time series data analysis because these are the most common time series data analysis. And I'm going to explain later what are these types of time series data that I'm talking about. So, all right. So if you have a time series data, the first step that you have to go through, imagine that this step as filters. So bayangkan kita ada satu data set. Data set ini akan melalui beberapa bentuk ataupun peringkat saringan dalam mendapatkan hasil yang berguna bagi kajian kita. Okay. Saringan-saringan inilah yang ditunjukkan di dalam carta yang kita ada di sini. Okay. The first filter, the first step that you have to go through to process the time series data is to conduct what we call as unit root test. Okay. Ini adalah langkah pertama yang kebiasaannya akan digunakan dalam memproses data siri massa, yaitu peringkat untuk menentukan sama ada data mempunyai unit root ataupun tidak. So, in unit root test, we wanted to determine whether our data is stationary or non-stationary. Remember, in a unit root test, once you have a time series data, first step is to conduct the unit root test. In a unit root test, you wanted to identify whether your data is stationary at level and at the first difference. Okay, so you need to identify whether your data is stationary at level and at the differences. So nanti saya akan tunjukkan tutorial bagaimana kita melakukan ujian unit root ini. Okay, so when your data contain unit root, that means your data is not stationary. Okay, but on the other way around, when your data did not contain a unit root, that means your data is stationary. Okay, bila data kita mempunyai unit root, okay, ini bermaksud data kita tidak pegun. Sebaliknya, jika data kita tidak mempunyai unit root, ini bermakna data kita pegun. Pegun dan tidak pegun menentukan kaedah yang kita gunakan dalam memproses data tersebut untuk menghasilkan maklumat yang berguna dalam kajian. So you have to test the unit, you have to conduct the unit root test for the data at level and at differences. Okay. Kita akan melakukan ujian unit root bagi data dalam bentuk nilai asas dan juga dalam bentuk nilai yang telah pun telah pun dibezakan, yang telah pun dilakukan pembezaan. Okay, differences means you simply subtract the current value of a data with the previous value of the data. So the result of the subtraction between current value and previous value will also have to be conducted. Okay, so you also have to identify whether these differences is stationary or not. Later I will show you, don't worry, later I will show you how to conduct the unit root test. So based on the unit root test, you have to identify whether your data is stationary or not stationary. And there are three possible consequences. Okay, three possible answers. One is that when you conduct the unit root test, you identify that all of the variables are stationary. All of the variables are stationary. Semua pembeli ubah. So you have to conduct the unit root test for the entire variables that you have. Okay, so if you have 4 variables, you have to conduct 8 unit root tests. One for at level, the other for the differences. So 2 times 4, you have 8 unit root tests basically. So if you identify that all of the data are stationary, bila kita mengenal pasti bahawa semua pembeli ubah adalah pegun, you can continue with what we call as least square methods in order to process or analyze the time series data. Second possible consequence is that you identify that all of the variable are non-stationary. Keempat-empat pembuli ubah adalah tidak pegun. So if you have these results, that means you have to go through another test known as co-integration test. Okay, ujian kointegrasi. Okay, and you will have 2 possible results. Your data or variable are co-integrated or your data are not co-integrated. Terdapat 2 kemungkinan hasil. Satu, data kita ataupun pembuli ubah kita berkointegrasi. Hasil kemungkinan kedua adalah data kita tidak berkointegrasi. If your data are co-integrated, if your variable are co-integrated, that means you have to conduct this analysis known as vector error correction modeling. Okay? Vector error correction modeling. on the other way around, if the variables are not co-integrated, that means you have to use another method of analysis for time series data known as vector auto-regressive model. Okay, so VECM is a modified version of VAR, where in VECM, you analyze variables that are co-integrated. And on the other way around, we use VAR to analyze data that or variable that are not co-integrated. Okay, kita gunakan VECM bila pembuli ubah kita berkointegrasi, dan sebaliknya kita gunakan VAR apabila data ataupun pembuli ubah kita tidak berkointegrasi. Co-integration test is simply the unit root test of our residual. Okay, co-integration test is simply the method of identifying whether the residual contain unit root or not. Okay, ujian kointegrasi hanyalah merujuk kepada ujian untuk menentukan sama ada unit root kita pegun ataupun tidak. Ujian untuk menentukan sama ada ini pegun ataupun tidak. Itu yang kita maksudkan sebagai ujian kointegrasi. Dan ada dua hasil seperti yang saya sebutkan. Hasil pertama, kita mungkin mendapati pembuli ubah kita berkointegrasi. Kemungkinan hasil kedua adalah kita mungkin mendapati kesemua pembuli ubah kita tidak berkointegrasi. The third possible result based on the first unit root test is that we may obtain a mixed stationarity. So ini adalah kebiasaannya yang saya akan, based on my personal experience, when I process time series data, most of the time I will meet this third possible result where the variables contain mixed stationarity. For example, if you have 4 variables, the first variable a non-stationary at level, second variable a non-stationary at level, second variable a non-stationary at level, and on the other hand, the fourth variable is stationary at level. So if you have mixed stationarity, then you have to use another version of model that we can use to analyze time series data known as ARDL, Auto-Regressive Distributed Lag. So kita menggunakan model ARDL bila kita mempunyai pembuli ubah yang mengalami ataupun memiliki pelbagai bentuk darjah kepegunan. Okay, in that case we will use the ARDL model. Of course, these are the 4 models that we can use. Okay, least square methods, VECM, VAR, ARDL. These are the 4 basic models that we can use to analyze time series data. And after we conducted these models, there are a number of diagnostic tests that we have to conduct in order to identify whether the results that we obtained are valid or not. Okay, selepas kita melakukan ujian ataupun proses VECM, VAR, ARDL ataupun least square method, kita perlu melalui proses yang terakhir yang dipanggil sebagai ujian diagnostik untuk menentukan sama ada hasil yang kita perolehi adalah valid ataupun tidak. But as I mentioned before this, there are various other methods that we can use to analyze time series data. There are various other methods that we can use. Okay? But these are the most basic that we can refer to in order to process our time series data. And keep in mind, I also put a note here. Please note whether your data is linear or non-linear, and please identify whether the data or the model is static or dynamic, because if you have data that is linear or non-linear, you may have to use different type of model in order to process the time series data. Unfortunately, I don't think that we have sufficient time, so we are not going to focus more on linear data. We will be focusing more on the linear data. And you also have to identify later on in your study, when you conduct your study, sometimes you have to identify whether your model should be static or dynamic. Sama ada data kita, model kita tu tadi, ini yang kita maksudkan sebagai model. Sama ada model kita itu static ataupun dynamic. Dynamic means we have to add the lag value of dependent variable as an additional independent variable. Itu yang dimaksudkan sebagai model dinamik, di mana kita memasukkan nilai sebelum bagi pembuli ubah bersandar sebagai pembuli ubah tambahan dalam pembuli ubah bebas kita. So itu yang dimaksudkan dengan dynamic. Static is simply this model where you don't have the lag value of y as an additional independent variable. I hope you guys paham apa yang saya maksudkan tadi. So let us do some tutorials. Okay, let us do some basic tutorials on how to process time series data. For that, let me introduce you guys with Gretel. Okay, let me introduce you all to Gretel. So if you have a laptop with you, I suggest that you download Gretel. Okay. In order to download Gretel, you can simply type GRETL. Okay. Type Gretel, and then after that, you can download it directly, but it depends whether you are using Windows or you're using a Mac operating system. Like me, for example, I use Windows, so I will select this one, the first option, Gretel for Windows. So if you're using a Mac OS, you can download the Mac OS version of Gretel. And then after that, if you're using Windows, of course, you have to determine what system that you are using for your operating system, for your Windows, whether you're using a 64-bit or you're using a 32-bit. So of course, it is simple on how to identify it. You can click on the setting, and then after that, look into the system. I hope that I'm not too fast. Just let me know if I am too fast to follow. From the system, you can already check. Okay, click about. Here you can see what system type that you have in your laptop, whether it is a 64-bit or 32-bit. But most commonly, we are using the 64-bit version of the operating system of the Windows. Okay, so once you identify that you are using a 64-bit, then you can click this one, 64. But of course, some are using the 32-bit option. But in my case, I'm using the 64-bit. So I click this one. Of course, it will automatically download the Gretel software. You will be directed to this what you call as menu. And yeah, you have the Gretel there, downloaded. And then after that, click install. After you completed in downloading the Gretel, just click install so that we can do the tutorial together. Because if we do the tutorial together, it will be more easy for you to understand rather than simply watching me doing the tutorial for you. Yeah. So I give you 5 minutes to download and install the Gretel so that we can do it together. So I encourage everyone to download and install if you are using a laptop and if you have sufficient data to download and install Gretel. Okay. So there it is. You can simply, what you call as, click and download. But in my case, I will cancel because I already have a Gretel. So later on, you can just click OK. Don't worry, it will be just fine. If say, for example, you don't want to use it later on because it will make it it will make your laptop slower. Don't worry, you can what you call as uninstall it later on after we complete our workshop. Okay, in my case, I cancel because I already have a Gradle. So kawan-kawan yang ada laptop, bolehlah download Gradle, ya. Pergi ke Google, kemudian type Gradle. Di sini kita ada dua pilihan, sama ada kita download bagi Windows ataupun bagi Mac OS. So kawan-kawan yang menggunakan Mac OS, you can simply use, you can click the Mac OS version of Gradle. If you're using Windows, you can click Windows. And after that, you identify whether you're using a 64 or 32-bit of operating system. Kalau kita tidak tahu apakah jenis operating system yang kita ada, don't worry, you can do a trial and error. Download dulu 64-bit, kemudian cuba install. Kalau tidak boleh, then kita download versi 32-bit. I do it sometimes, especially when I don't know especially when I try to install a Gradle in a laptop that I don't know whether I'm using 32-bit or 64-bit. So 5 minutes for you guys to download and install. And if you have any question, please feel free to ask. Boleh tanya dalam bahasa Malaysia, boleh juga in English. Kita cuba untuk entertain as many questions as possible. So the reason why I am using Gradle is because it is a free software. Okay, it is a free software, and it is quite what you call as it is quite okay, quite comprehensive. It is quite comprehensive to use in order to analyze time series and panel data model as well. Okay, Gradle adalah software yang free dan agak komprehensif, agak menyeluruh. Of course, it is limited if you compare it with eViews or Stata, for example. But of course, in order for you to get an eViews or Stata, you have to purchase them. Okay. But of course, if you have those what you call as a statistical software, then it is okay. It is okay. But in this tutorial, we will try to use Gradle. So semua sudah download dan install. Okay, yeah, don't worry, take your time, still downloading. Yeah, I understand that some of us have this difficulty in downloading due to, you know, internet connection. Don't worry about that. I will give you some times to download and install. And for the rest of you guys, if you have other questions, you can just pose it. So yeah, we have a question here. Doctor, this time series is a quasi design. Well, quasi design, unfortunately, I'm not familiar with this term quasi design actually. I'm not really sure what it is. I'm not really sure what does it mean by quasi design. So it is sad for me to say that I can't give you the exact answer for that one. Quasi design method. Are you referring to the mixed methods? So I'm not sure about that. Yeah, I can't give you the exact answer whether time series is a quasi design or not. Yeah, because uh, I'm not sure whether I have seen that terms before this. Unfortunately, we are focusing towards quantitative data analysis. We are focusing on the quantitative data analysis. Yeah. So if quasi design methods is qualitative, then I don't think that we can use time series data in order to analyze that methods. In other words, I don't think that quasi design method belongs to the time series data analysis. That is just my opinion because I'm not really sure whether quasi design method is a type of time series data. I cannot give you the exact answer, but in my opinion, perhaps that quasi design method is not, we cannot consider them to be time series data analysis. So another minute for you to download and install the Gretel. So here it states that quasi-experimental time series analysis is a method of statistical analysis involving tracking a long-term period before and after a point of intervention. So I'm not really sure, unfortunately, I'm not really sure whether quasi-experimental is a type of time series, but sometimes it says here that quasi-experimental can also be considered. Okay? Some type of quasi-experimental is a time series data analysis, but we are not going to focus into the quasi-experimental. Okay, we are not going to focus into that one. We are just going to focus into a more common method of analyzing time series data. Methods that I showed, the 4 methods that I showed just now. So I think that's it. Now I'll try to show you on how to process a time series data. Okay, a time series data by using Gretel. Yeah, I'm sorry again because I cannot answer your question. I don't have sufficient knowledge to answer your question. Maybe you can try to ask that question to someone that is, well experienced. There are many lecturers, especially in the faculty, that are well experienced with vast knowledge. You can try to ask them, what does it mean by quasi-experimental research or quasi-design methods, and whether you can employ time series data in order to analyze the methods, or in other words, whether quasi-design method is a type of time series data analysis or not. You can try to pose that questions to to the academics that are more well versed. There are many lecturers in the faculty that I think can answer your questions more clearly. Yeah. So without further ado, let us go. So if you guys have downloaded and installed Gretel, you can open the software. You can open the software. So open Gretel. I hope that you guys can see my screen. Can you guys see my screen? Okay, you guys can see it, right? Puan Eli, boleh nampak screen saya?
Tidak nampak.
Kalau saya tutup begini, I mean kalau saya buka, dapat nampak?
Ya, dapat.
Okay, thank you, Puan. Yeah, just for confirmation, guys. All right, so now we open the Gretel. Okay, this time I'm going to show you the 4 methods that we can use to analyze time series data. Okay, the 4 methods that we can use time series data. All right. Okay. So click File, and then after that, open data. Fortunately, in Gretel statistical software, we have sample files that we can use. Okay, we have sample files that we can use to show or to make exercise on how to analyze time series data. So click sample file. So we have a number of sources that we can choose the file from. So let us look into choose green. Not sure if it is green or Ramanathan. Okay, choose Ramanathan. So this is actually, I believe this is a textbook. Yeah, in that textbook you have various data that you can process. So click annual US macroeconomic data. So here we have a number of time series data. Okay, you know that it is a time series data because you have an attribute. Sorry, you have one subject but various time periods. In this case, from 1959 to 1993. So you have one subject, you have various time periods from 1959 to 1993 in this case. So you open this, what you call a sample file. So this is a sample file that we will try to use in order to show you how to process a time series data. So once you open this file, first step, as we mentioned before this, is to conduct the unit root test. Okay, we conduct the unit root test. In order to conduct a unit root test in Gretel, simply choose the variable. In this case, I choose GDP. Okay, we will try to understand in this case whether GDP is influenced by personal consumption, gross private domestic investment, export, in government purchases or not. So we have 1, 2, 3, 4, 5 variables. Okay, so our dependent variable will be GDP, our independent variable will be consumption, investment, export, and government purchases. Okay, due to time limitation, we are not going to process the entire, we are not going to use the entire variables because we have time limitation. So we're just going to focus into these 5 variables, GDP as the dependent variable. So click, if you wanted to conduct the unit root test, which is the first step of analyzing a time series data, unit root test, click GDP, choose GDP, and then click variable. Then click unit truth tests. Okay, click unit truth tests. Of course, there are various methods that you can use to test the variable, whether it contains unit root or not. But in this discussion, we can try to choose the augmented Dickey-Fuller test, or simply known as the ADF test. This is the most common method used to test whether our variable is stationary or not. So choose ADF, and then here we have a number of options. Okay, we can have a number of options. So you can use, or you can choose the leg order for the ADF test. You can choose up to as many as you want. But of course, sometimes we can limit the maximum leg order for our ADF test into 8. Yeah. And then after that, you also have a number of additional options. For example, the criterion that you will use. Okay. Whether you are using the Akaiki info criterion, you can also use the Bayesian info criterion or P statistic based on Gretel. In our case, let's just leave the other option as in the default mode. Of course, in the ADF test, we can also test whether the model include constant or constant with trend. We can also choose whether to test the variable without constant, or we test it with constant, trend, and trend squared. In our case, let us assume that the variable, we test the variable for unit root with constant and trend. Okay, and then as I mentioned before this, you conduct the unit root test for 2 levels. Okay, you conduct the unit root test at level, and you conduct the unit root test at the first difference, because you need to identify whether your data is stationary at level and whether it is stationary at the first difference. Okay, so choose at level first, and then click OK. Click OK. So here we have the results for our unit root test based on the augmented Dickey-Fuller. So one of the key information is to look into the asymptotic p-value to determine whether your data is stationary or not. Okay, so here we can see that our data is significant at 10% level. That means, okay, that means our data is stationary at level with the significance level of 10%. Okay, it means that our data is stationary at level. You repeat the same process again. Click variable, unit root test, augmented Dickey-Fuller. Now you test the first difference, unit root existence. Click OK. Here, look into the asymptotic p-value again. You can see that the variable is also stationary at the first difference because it doesn't contain unit root. Remember, if the variable doesn't contain unit root, that means the variable is stationary at that, what you call it, level, be it at level or be it at the first difference. So we know our GDP is stationary at level and at the first difference. So you repeat the same process again. Okay, for consumption this time, repeat unit root test, ADF test. So you leave the other options and then click OK. So here, look into the p-value again. This time it is insignificant. If it is insignificant, that means the variable contain unit root at that stage. Okay? If the variable contain unit root at that stage, that means the variable is non-stationary at that stage. Since we conduct this ADF test at level, we can simply say that the consumption Okay, we can simply say that the consumption expenditure is not stationary at level. Okay, apart from this key information, you can also look into the number of maximum lag used. So Gretel will automatically determine what are the maximum lag to process or to identify the existence of unit root. In this case, Gretel determines that lag 1 is included to test our unit root. So we repeat the same process again for consumption. Okay, you repeat the same process again for consumption, but this time we use at the first difference. So we can see in this case that the p-value is significance. If it is significance, that means the variable did not contain unit root. In other words, the variable, in this case, consumption, is stationary at the first difference. So it is non-stationary at level, but it is stationary at the first difference. Now, look into the number of lag included. In this case, it uses 1 lag as well. Okay. It is very important for us to determine for the number of lag included, because we will later have to refer to that information in order to decide the number of lag that we have to use in order to run, in order to test our, or in order to analyze our time series data. So you repeat the same process again for investment, for export, and for government purchases. You repeat the same process again, conduct the unit root test for both stages. Unit root test at level and unit root test at the first difference for each of the variables that we have. Since we have 5 variables, we have to repeat the unit root test 10 times, 2 for each of the variable that we have. And you can already see, initially you can already see at the first step, you can already see that our GDP is stationary at level and it is stationary at the first difference, while consumption is non-stationary at level, but it is stationary at the first difference. So in that case, you can already assume that we are having a mixed stationarity. So kita mengalami satu bentuk keadaan di mana pembuli ubah kita mempunyai kepegunan yang pelbagai, di mana ada pembuli ubah yang pegun. Pegun dalam slide ini bermaksud pegun pada level, okay? Stationary at level, okay? Pegun bermaksud stationary at level. In this slide, stationary means stationary at level, okay? Non-stationary, on the other hand, means non-stationary at level. All the variables are non-stationary at level. Mixed stationary, on the other hand, means some of the variables are stationary at level, like GDP, while the other variables are non-stationary at level, but stationary at the first difference. For example, in our case, the investment, the consumption. Okay. For example, the consumption is stationary, non-stationary at level, but stationary at the first difference. Assume that all of the variable, even though that we know we have mixed stationarity, assume that all of the variables that we have are stationary. Andaikan semua pembuli ubah yang kita ada pegun pada level, okay? Pegun pada level means that all of the variables that we have are stationary at level. Semua sama seperti GDP, pegun pada level. So in that case, we can choose to use the least square methods in order to analyze our time series data. So in order to use the least square methods, click model, okay? Click model, and then after that, choose ordinary least square, okay? Choose ordinary least square, OLS. Then here we have a number of options, okay? We have to include the data for the dependent variable. We also have to include the data for the regresses. Means we include the data for our independent variables. And you can also see that Gretel will automatically include the constant. constant is the intercept. Okay, the intercept that I'm referring to before this. This one is our constant. And then after that, we include the dependent variable, choose. Okay, now it is included in the dependent variable. And we include the consumption, the investment, export, and then we also include the government expenditure as the dependent, as the independent variables. So we have 4 independent variables, we have 1 dependent variable. Leave the other way, leave the other options in the default mode. So simply click OK. Here we have the results of our OLS. Okay, as I mentioned before this, in a time series analysis, among other objectives, we are also need to refer to the coefficients and the sign of the coefficients. Okay, terdapat pelbagai objektif dalam membuat kajian. Okay, antara 2 objektif yang umum adalah untuk menentukan nilai pekali kita, nilai koefisien, dan juga menentukan simbol bagi pekali kita, sama ada positif ataupun negatif. In this case, you can clearly see that all of the independent variable are positive. That means all of these independent variable are positively related to the GDP. So this is our dependent variable. These 4, on the other hand, are our independent variables. So they are positively related to our dependent variable. Apart from that, you can also see the value of our coefficient, and keep in mind to look into the significance level, because even though we have certain value and the sign is also as expected, but if the significance level shows an insignificant, that means we can clearly say that that variable is insignificant in influencing the dependent variable. So here we have a few asterisks that you can refer to. 3, sometimes you can have 2, sometimes you can have 1 asterisk. Kadang-kadang kita ada 3 bintang, kadang-kadang kita akan ada 2 bintang di hujung model ini, dan kadang-kadang kita ada 1 bintang ataupun tidak ada bintang. So bintang ini merujuk kepada significance level. If you have 3 star, that means this variable is significant at 1% level. Bermaksud pembuli ubah ini adalah significant dalam mempengaruhi, in this case consumption is significance in influencing GDP at 1% level, which is the highest percentage for significance level, 1%. And investment is also significant. Same goes to export in government expenditure. So in this result, we can conclude that all the independent variables are significant in influencing the gross domestic, in influencing our dependent variable, And don't forget, as I mentioned before this, there are a number of diagnostic tests that we have to go through in order to validate the results that we obtain from our time series model. Okay, so these results, these diagnostic tests are varied depending on what type of model that we use. So for ordinary least square, there are a number of diagnostic tests that you have to follow. Same goes to VECM, VAR, and ARDL model. So there are 3 common diagnostic tests that we have to conduct in order to identify whether the result that we have are valid or not. Number 1, we have to identify whether our model contains serial correlation or not. Okay, so serial correlation means the residuals or the error terms are different, okay, between time periods. Okay, the serial correlation means that the error terms are correlated across time. Okay, means that there is a relationship between the error terms from the current period to the previous period and the the future periods as well. So in that case, we are having a problem or an issue in our model name as serial correlation. So if you have a serial correlation in the model, in the estimation, then it will affect the efficiency of your estimation. Okay, it will affect the efficiency of your estimation. In other words, you cannot simply use the result that you obtain in order to conclude the relationship between dependent and the independent variables. Of course, there are a number of tests that we can conduct depending on which model that we use. So we have Durbin-Watson, we have Rouch-Galfrey test that we can use to test the serial correlation. Number two, we have to test whether our model contains heteroskedasticity. Okay, heteroskedasticity refers to the condition where the variances of our residuals are not equal across time. Okay, if they are not equal across time, that means the model that we use is only valid for one time period. So we have to conduct multiple time periods. But of course, we cannot do so because it will be time consuming and it will be inefficient to do so. So the consequence of the existence of heteroskedasticity is that the SE or the standard error that we obtain will be biased. So if the standard error that we obtain is biased, then the inference that we obtain from the data will be non-reliable. In other words, we cannot say that there is a significant relationship between the dependent and the independent variable if we have heteroskedasticity in the model, because the inferences will be biased. So inference yang kita lakukan bagi dalam membuat perhubungan, dalam merumuskan perhubungan di antara pembeli ubah bebas dan pembeli ubah bersandar adalah bias jika kita mengalami masalah heteroskedasticity. And of course, there are some tests that we conduct to identify whether our model contains heteroskedasticity or not. We have Rouch-Pagan test, we have ARC test, we have white test. Unfortunately, in Gretel, we have very minimal choices. We have very minimal choices of tests that we can use to identify whether our model contains heteroskedasticity or not. And of course, there are a number of remedies that we can use, if we can call it remedies. Okey, ada pelbagai langkah yang kita boleh lakukan dalam memperbetulkan ataupun memperbaiki model kita. Dan yang paling popular adalah menggunakan robust standard error, because heteroskedasticity causes the standard error to be biased. So all that we have to do is to use a robust standard error in order to correct our inferences, in order to correct the standard error, thus improving the inference that we obtain from our data. For a serial correlation, among the remedies will be to remove certain variables in our model, or we can also transform the variables in our models. The third common diagnostic test that we use is the normality test. Okay, maksudnya kita akan cuba untuk menentukan sama ada residual kita, sama ada error term yang kita ada itu normally distributed ataupun tidak. Okay, tapi normality test ini kita lakukan kebiasaannya untuk sample size yang sedikit, less than 200. If you have huge sample size, then it is most unlikely, okay, least likely for you to encounter the non-normality in the residual. Most likely you will have a normal distributed residual if the sample size is huge, 200 or even higher than that. And of course, certain models require additional diagnostic tests. For example, if you're using an ARDL test, you have to test the stability of your model. You have to test as well whether your data is correctly specified or not based on what you call as Ramsey reset test. Okay. But I don't think that we have enough time to do an ARDL model, but don't worry, I will try to what you call as a record on methods to conduct the ARDL model and then post it in YouTube. And if you have time, you can simply, I haven't created the what you call as videos yet, but later on I will, if I have time, I will show you on how to process the data based on the ARDL model, because we have time limitation. Yeah. So yeah, back to our tutorial. So this is our OLS results. So we are in this process, yeah, where we assume that all this data are stationary. Yeah. Then, in order to conduct the diagnostic test, you have a number of options for tests. Here we have a few options. First, you can conduct the heteroscedasticity test. We may use the Bruch-Pagan in order to test the heteroscedasticity. So you have this pop-up menu. You can simply close it because the result will be recorded in our main menu. So here the null hypothesis states that heteroscedasticity is not present. So if you fail to reject the null hypothesis, that means you can assume the model to be free from heteroscedasticity. So here, refer to the p-value. Since the p-value is insignificant, that means we will fail to reject the null hypothesis. If we fail to reject the null hypothesis, we can safely say that we are free. I mean, the model is free from heteroscedasticity. Next test, we can refer to the normality of the residual. Okay, just like the heteroscedasticity, I'm going to show you the quick way of identifying whether we have problems in our model or not. Just close the pop-up menus, refer to the result that is recorded in our main menu. So here, the null hypothesis states that the error is normally distributed. So if you fail to reject the the null hypothesis, just like in this case, then we can simply say that our residuals is normally distributed, which is good. Now you can conduct the serial correlation. Okay, so here, okay, you can test how many lag orders. Okay, you can choose 1 or 2. So here we choose 1 to test the autocorrelation. So in this case, the autocorrelation is tested based on the Lagrange multiplier test, the LM test for autocorrelation. So the null hypothesis states that there is no autocorrelation, but if you reject the null hypothesis, then it means that your data suffer from autocorrelation. And in this case, you can clearly say that we have we have rejected the null hypothesis. In other words, we have autocorrelation issue in our model. Okay, we have autocorrelation issue, this issue here. So you have to correct the model, okay, based on these remedies. Maybe you can drop certain variables, you can add additional variables, or you can also transform the variables, say, into natural logarithm. Okay, in order to improve the data. Of course, in doing a time series data analysis, sometimes we have to do some sort of trial and error. Okay, in order to identify the most sufficient model to analyze the relationship between independent and the independent variables. So, of course, apart from conducting the LM test to identify the autocorrelation, you can also refer to the Durbin-Watson test. Okay, you can also refer to the Durbin-Watson test. So this Durbin-Watson test clearly say that we have an autocorrelation issue in our model, because when the Durbin-Watson is between 0 to 2, that means you have a negative autocorrelation. Sorry, you have a positive autocorrelation. It is indicated in the row here as well, a positive correlation. If the Durbin-Watson is 2, that means you don't have, or you are free from autocorrelation. And on the other hand, if you have Durbin-Watson value between 2 to 4, that means you have a negative autocorrelation. So the most ideal Durbin-Watson value will be 2, because 2.00 means that you are free from autocorrelation in the model. If it is 0 to 2, that means you have a negative, as you have a positive autocorrelation. If you have 2 to 4, that means you have a negative autocorrelation. But if you have exactly 2 or close to 2, approaching 2, That means you have less issue of autocorrelation. Okay? So, but of course, the most absolute way to determine whether you have an autocorrelation problem or not is by conducting the LM test for autocorrelation. And if you're using Pgws, for example, Stata, then you have various other methods to conduct the serial correlation test. But for our what you call as discussion, the autocorrelation test conducted based on Gretel is good enough. So we can clearly say for example, we are free from heteroscedasticity. Say that we have a normally distributed residual and we are free from autocorrelation. Then we can conclude that there is a significant relationship between variables between consumption, investment, export, and government expenditure towards GDP, where the relationship between this dependent variable and the independent variable are positive. So when consumption, investment, export, and government expenditure increases, GDP will increase as well. Okay, so when consumption increases by 1 unit, GDP will increase by 0.96 unit. Yeah. When investment increases by 1 unit, GDP will increase by 0.81 unit. So same goes to export and government expenditure. When they increases, GDP will increase based on certain value, okay, depending on the value of the coefficient. But sometimes, most of the time, researcher prefer to transform the model into natural logarithm, because once they transform the value or the variables into natural logarithm, then it will be more convenient for them to interpret the relationship between variables. For example, if we transform these variables into natural logarithm, so that we transform GDP, constant, investment, export and government expenditure, we transform them into natural logarithm. So here you can simply right click. So we have the option to add logs. So it refers to natural logarithm. So we have this, what you call as transform version of the previous variable. Run the OLS again. In this case, instead of using add level, you are using the transform version of the variables. And click constant, include investment, export, and government expenditure as well. Here you have the results, and it will be more convenient to interpret them. Why I say that it is more convenient? But remember, okay, you cannot simply transform if you don't understand the function of the transformation. Okay, you have to know what you are doing at first before you transform the model, because it's convenient in some way, it doesn't mean that it will be universally convenient. Yeah, just like it is convenient for us to use airplane from Sabah to KL, but it is not going to be convenient to use airplane to go from KK to UMS. It will be more convenient to use motorcycle, for example. So transformation, even though they are convenient in certain way, it doesn't mean that they are convenient universally. So you have to understand the purpose of transforming the variable. So in this case, we are transforming the variable in order to make it, to show that it is more convenient to interpret them. Yeah. For example, here we have the result for log consumption. So we have a coefficient value of 0.4983. So that means that when you interpret the relationship between consumption and GDP, you can say that when consumption increases by 1%, GDP will increase by 49%. So that is how we interpret the relationship if we log transform the variable. Do you have any question? So yeah, if I can recall back to some of these questions, I use panel data. Panel data includes time series data. So I must do unit root test. Well, it depends. You can also conduct unit root test for certain panel data. For example, if you wanted to conduct the panel ARDL, then you have to conduct the unit root test for panel data. But there is a specific function that you can use in order to test the unit root for panel data. But some of the panel data model doesn't require unit root tests. Yeah, it doesn't require unit root tests. For example, if you are conducting random effects, if you're conducting a fixed effects, a GMM, then it is not necessary for you to conduct the unit root test for that particular panel data. All right. So we have time limitation. We only have what 13 minutes left. So I will try to speed up our discussion. I don't think that we can reach the time series data. So I will move into the next type of model for time series analysis, which is the VECM, yeah, vector error correction modeling. So assume that our data contain unit root at level, means that they are non-stationary at level, and we conduct in that case, we have to conduct the co-integration test. So in order to conduct the co-integration test, simply choose model and click multivariate time series. So we have a number of co-integration tests here. We have Johansson and we have the Engelgranger. But say that we conduct, the most simplest way will be to conduct the Engelgranger co-integration test in order to identify whether the residual contains unit root or not. So the co-integration test is important in order to choose whether we are going to identify, we are going to apply the VAR or the VECM model to analyze the time series data. So click co-integration test. So here we have this pop-up option. Okay, so include all the variable of interest. So we have GDP, consumption, investment, export, and we also have the government expenditure. So remember before this, I asked you to refer to the maximum lag used to determine the unit root. Well, we have to refer to the maximum lag used in order to determine what are the maximum lag order that we wanted to use in order to test the co-integration based on Engelgranger. So assume that we are choosing lag number or lag order up to 4 lags. Assume that we are using lag order up to 4. Later, you have to conduct the test one by one in order to determine what are the maximum lag order to include in order to test the co-integration for your model. Okay, and then skip the Dickey-Fuller test, test down from maximum lag order, and then leave the other into the default mode. You don't have to choose between AIC or BIC, just choose AIC and then click OK. So here we have what we call as the result for our co-integration test. So based on Gretel, okay, based on Gretel, you have to test for in order for you to determine whether you have co-integration or not, you have to refer to two hypotheses. One is that the unit root hypothesis is not rejected for the individual variables, and the unit root hypothesis is rejected for the residual co-integrating variables. Okay, for the residual, the unit root hypothesis is rejected for the residual from the co-integrating regression. Okay, in other words, we can only assume that we have a co-integration relationship if number one, you contain unit root at level for all of the variables that we have, and we are assuming that we are having that situation. We are having a unit root at level. And then number two, we have the unit root hypothesis rejected for the residual. Okay, in order to determine whether you have unit root for the residual, refer to the testing for unit root 4, in this case, residual, denoted by the term U hat. Refer to the asymptotic p-value. Okay, you refer to the asymptotic p-value. So if the p-value, okay, if the p-value should not reject, so if the p-value is significant, you do not reject the unit root for the variable. Okay, number 2, if the p-value is significant, if I can repeat it again, you have to conduct the unit root test for the variables that we have. That's number 1, and we are assuming that one already. We are assuming that we have unit root at level. Number 2, in order to determine that we have a co-integrating relationship or not, we have to conduct the unit root for the residual. Okay, so here we have the result for the unit root test of the residual, and based on the p-value, the unit root test is insignificant. Okay, in other words, the p-value shows insignificant. If it is insignificance, you can read here, the hypothesis, unit root hypothesis is rejected for the residual from the co-integrating relationship. Okay, so in other words, we have to assume that the models contain or did not contain co-integration. In other words, the variables are not co-integrated. Okay? The variables are not co-integrated. So do you have any questions so far? Because I'm afraid that you might miss some of the important information. Do you have any questions so far? No question. All right. Okay. So let us continue. All right. Again, here I'm trying to say whether this insignificant means that the unit root hypothesis is rejected, thus residual is not co-integrated or not. This is evidence for a co-integrating relationship. So give me some time to read these terms, because I wanted to identify whether if we reject the p-value, if we have an insignificant unit root test, that means we have to reject the null hypothesis of no co-integration, or we have to reject the null hypothesis of co-integrating regression. All right. Okay. In this case, since the unit root is failed to be rejected, okay, the unit root hypothesis is failed to be rejected, that means we don't have a co-integrating relationship. Okay, that means we don't have a co-integrating relationship. I repeat, let me correct my mistake before this. If you have a p-value that is insignificant, that means you fail to reject the null hypothesis. Okay, you fail to reject the null hypothesis of a non-co-integration. Yeah, you fail to reject the null hypothesis, and the null hypothesis states that the variable are not co-integrated. Remember, if the p-value is not significant, that means the model is not co-integrated. If the p-value is significant, that means the model is co-integrated. So if the model is co-integrated, you're going to use VECM, but if the model is not co-integrated, you have to use the VAR option. All right, assume that in this case, we don't have a co-integrating model, just like what we have in this result. The p-value shows insignificance. We fail to reject the null hypothesis of no co-integrating relationship. In other words, our model is not co-integrated. If it is not co-integrated, we have to conduct the VAR test. So we conduct the VAR test for our variable. In order to conduct the VAR test, we are in this stage, okay? We identify that the model is not co-integrated, so we conduct the VAR test. In order to conduct the VAR test, you need to at first determine the lag selection for VAR. Lag selection for VAR. So we have all the variables here, including the dependent variable. Choose, say for example, we choose up to maximum lag of 4. Okay. Include a constant. You don't have to include a trend. So this is method of determining the number of lag used for our VAR model. Click OK. So we have the result, and the result states that the optimum lags is 4. Okay, the optimum lags is 4 because both IKK criterion and Hannan-Quinn criterion suggest that lag 4 is the most sufficient model for our VAR. Okay. Even though we have another one, Schwartz Bayesian criterion here, who suggests that lag 2 is the most optimum, let us choose 4 because both AIC and H2C tells us that the most sufficient lag, the most appropriate lag to include is 4. So we include lag 4. So close this one again, and then click model, multivariate time series, choose VAR, vector auto regression. So here we have VAR, and then before this, if you can still remember, we have how many lags? We have lags up to 3, we have lags up to 4. So say that we include lag 4. Yeah. So remember that in order to determine that one, you have to determine the lag selections, the most optimal. Sorry, the most optimal lag selection. If I can show it to you again, say that we choose up to 4. So here we have lag 4 is the most appropriate. Then after you determine the lag selection, choose vector auto regression, and here you include lag 4 and include all the variables as endogenous variable, and you don't have to include any variable as exogenous. But remember, it depends on the assumptions that you have in your VAR model. Some of the assumption requires you to include exogenous variable, but some of the assumption doesn't require you to include in exogenous variables. So the choices, the options that we choose depends on the assumptions that we include, that we impose in our model. So click OK. So here we have the results of our VAR model. So there are a number of what you call as key information that we can look at, that we can refer to. For example, we have the individual. Okay, so we will have the Gretel will process a number of equations depending on the number of variables that we have. Okay, depending on the number of variables that we have. If you have 5 variables, then Gretel will produce 5 equations. Yeah, just like what we have in this discussion. But our main focus will be towards equation 1, where our dependent variable is the GDP. And our independent variable, on the other hand, will be the lag value of GDP and our other dependent variables, namely the consumption, investment, export, and government expenditure. So you can also see the relationship between individual independent variables, okay, based on their lag value towards GDP. For example, lag 1, gross domestic product, is significant in influencing GDP. Lag 2, GDP is insignificant in influencing the GDP, current GDP. Lag 3, previous 3 values of GDP, is significant in influencing the GDP. So you can repeat the same explanation for the other independent variables. Apart from that, you can also look into the F-test for zero restrictions. So these F-tests will show the joint significance for each of the independent variables in their lags towards GDP. For example, here we have all lags for consumption, and we have p-value that shows significance. Yeah, so 0.0383 is significance at 5% level. That means all lags of consumption, from consumption 1 lag until consumption 4 lag, are significant. Sorry, is significant, is jointly significant in influencing our GDP. So nilai F-test ini menunjukkan sama ada pembeli ubah kita yang merangkumi ke semua lag adalah signifikan dalam mempengaruhi pembeli ubah bebas ataupun tidak. So jika nilai F-test kita adalah signifikan, sebagai contohnya consumption di sini adalah signifikan, investment significant at 5%, export is significant at 10%, and government expenditure is significant at 5%. So if they are significant, that means each of these variables, each of these independent variables are significant, are jointly significant in influencing our dependent variable, which is the gross domestic product. They are jointly significant. Their lags from lag 1 until lag 4 are jointly significant in influencing GDP. Jadi nilai lag bagi consumption dari nilai lag pertama hingga nilai lag keempat adalah signifikan dalam mempengaruhi GDP. Nilai lag bagi investment daripada lag pertama hingga lag keempat adalah signifikan dalam mempengaruhi GDP, dan huraian yang sama boleh dilakukan bagi ekspor dan GDP kerana kesemua pembeli ubah are jointly significant in their lags in influencing or in explaining the movement of our dependent variable, in this case, the GDP. So we have exceeded 2 p.m. I'm not really sure if we can get additional time, because we still have the VECM and DERDL as well as the panel data series that I plan to show, but I'm not really sure. Puan Eli, adakah kita boleh ada masa tambahan untuk bincang VECM dan juga model-model yang lain, ataupun
boleh
option? Boleh?
Kalau doktor mau teruskan silakan.
Boleh. What about the rest of you guys? Do you need maybe 5 minutes of break? Kamu perlukan masa untuk rehat ataupun macam mana? Untuk saya tunjukkan model-model yang lain. Well, I'm not sure whether this recording will be emailed or not. It's up to Puan Eli. Okay, 5 minutes break. Okay, let's break for 5 minutes. Kita rehat dulu. Usually in kita ada Dr. Jarat sini. So Dr. Jarat say this supposed to be a 4 days courses. Unfortunately, we don't have 4 days. So we take a break for 5 minutes. Yeah, we take a break for 5 minutes before we continue with the remaining models. Yeah, before we continue with the remaining models. Yang lain, if you wanted to ask questions, you can simply post it in the chat room over there, or you can ask me directly. Yeah. So I am sorry again kalau saya boleh refer kepada Raza alias tadi yang bertanya tentang quasi design methods. So saya rasa kaedah yang terbaik, option yang terbaik adalah dengan merujuk kepada SB kita ataupun merujuk kepada pensyarah yang lain yang berpengalaman untuk menjawab soalan Razali dengan lebih tepat lagi, yeah, because unfortunately, I don't have enough experience to answer or to address your question. Untuk pelajar-pelajar tahun akhir yang membuat latihan ilmiah, dan kita faham pelajar-pelajar ini mempunyai kekangan, ya, kekangan dari segi masa dan kekangan dalam mendapatkan statistical software yang boleh digunakan untuk memproses data. Lebih-lebih lagi pelajar yang menggunakan data secondary dalam bentuk kuantitatif. So untuk itu adalah ideal untuk kita menggunakan Gretel, karena Gretel yang pertama sekali kita boleh download secara online, but of course kita juga perlu merujuk kepada objektif yang kita ingin capai dalam latihan ilmiah kita. Kita perlu rujuk sama ada objektif ini mampu dicapai menggunakan Gretel ataupun menggunakan statistical software yang lain. Jika kita terpaksa menggunakan statistical software yang lain, maka kita perlu mencari cara macam mana untuk mendapatkan statistical software tersebut. Mungkin bertanya kepada SV ataupun cuba bertanya kepada JTMK jika mereka boleh provide us with the statistical software. If you cannot choose or use Gretel to process your data in order to retrieve information to use for your latihan ilmiah, I mean the laporan for latihan ilmiah. But yeah, when I was doing my bachelor degree, I still remember some of my friends are using Gretel actually in order to do their thesis. Yeah, in order to do their thesis, because in our university we have these options whether we choose a thesis, whether we conduct what you call as a what do you call the internship? I forgot the name for that one. Latihan industry, sorry, and or whether we add additional papers. But some of my friends choose to conduct thesis and they use Gretel to run the analysis. So I hope that when you're conducting your analysis using Gretel, you can also manage to process your data sufficiently in order to retrieve relevant information. Yes, it can be used for mixed method as well, but depending, as I mentioned before this, it depends. It depends on certain situation. It depends on certain situations. In some model, Gretel allows you to process mixed methods. Yeah, in some model, you can use Gretel to process mixed methods. Yes, Dr. Jarat, we can also import data from Excel. You can simply click Excel and then drag it on the Gretel menu and drop it there. So Gretel will automatically determine whether your data is time series panel data or cross-sectional data. Yeah, but of course you can also import. Okay, apart from dragging your file into Gretel, you can also import your data as well. Okay, and it is Excel friendly, means you can also analyze Excel file using Gretel. Yes, unfortunately, kita tidak ada Philips Piron unit root test for Gretel. So, in that sense, Gretel is somewhat limited compared to statistical software such as Pgws or maybe Stata. But of course, there are other options, if you can call it options, to conduct relevant tests. For example, if you conduct the unit root test, if you cannot find PP test, then you can use the augmented decay folder test. even though some of us prefer to use both PP, Phillips Perron test, and augmented Dickey-Fuller test when we conduct the unit truth test in order to determine the stationarity of our variable. So 1 minute, ya, kita ada 1 minit lagi sebelum kita continue kita punya discussion. We have remaining 1 minute before we continue our discussion. And again, I am sorry that before this, at the beginning of our discussion, I forgot to show you, you know, the slides show. I totally forgot to press the presentation button in our Google Meet. Okay, now let us continue our discussion on methods to process time series data. So yes, Dr. Jarat, one of the convenient attribute of Gretel is that it shows you the hypothesis null. So remember, guys, so in a test, we have two hypotheses. In each of the models that we have, basically we have two hypotheses, null and hypothesis alternative. Yeah. So if we reject H null, that means we accept H alternative. Yeah. On the other hand, in the other way around, if we fail to reject H null, that means that we fail to accept the H alternative. So in a test, basically what we do is to determine whether we reject or fail to reject H null. So the good thing about Gretel is that it shows you the H null of a test, so that it helps you to decide whether you have issues such as autocorrelation or not, whether you are free from serial correlation or not, whether you are free from heteroscedasticity or not. So it helps you a lot in terms of deciding, whether to reject or fail to reject H null. And what does it mean by rejecting or fail to reject the H null? So that is the good thing about Gretel. Okay, all right. So now we continue our discussion. Let's continue our discussion. Okay, before this, since when we conduct, okay, let me present you my entire screen so that it will be easy for you to see what I'm doing here. So, I mean, in this presentation, before this, so can you see the slides? I hope that you can see the slides. Okay, so now remember, before this, when we conduct the unit truth test, we assume that all the data that we have are not stationary at level. So we are in this stage. And when we conduct the co-integration test, remember, when we conduct the co-integration test before this, we identify that the data are not co-integrated. Okay, the data are not co-integrated. But say, for example, when we conduct the co-integration test, remember, this is the co-integration test again, if I can show it to you. Engel-Granger test is the most simplest method to determine whether our variables are co-integrated or not. The difference between Engel-Granger and Johansson is that the Engelgranger test for the co-integration for a single vector, while Johansson conduct the co-integration test for a multiple vectors. So, but in our discussion, we can simply use the co-integration test based on Engelgranger or Engelgranger. So if I can show it to you again, you can skip the initial decay full test, or you can also show it. And then you can choose lag number. In this case, let us choose 4 lag order. Okay. So here, now in this case, okay, if we choose to show the results of the regressions, yeah, in our option in conducting the co-integration test for the Engelgranger, you can see that we can also determine whether we have the unit root test for the individual variables or not. Remember, the evidence of co-integrating relationship is proven when, number one, unit root hypothesis is not rejected for the individual variables. So you have 5 variables. Okay, so here they are not rejected. They are not rejected. Our hypothesis null are not rejected. In this case, export are not rejected as well. Government expenditure are not rejected as well. So we fail to reject. Okay, we fail to reject the hypothesis null of unit root. In other words, we have unit root for the individual variables at level. So that's the first, that's the first indicator of an existence of co-integrating relationship. Second, second is to determine whether our unit root hypothesis or our null hypothesis is rejected or not for the unit root test on our residual. So this is the unit root test for our residual, and it states that we fail to reject the H null. Okay, if we fail to reject H null, then we cannot say that our relationship is, or our model is, co-integrated. Okay, that is why we choose the VAR. But assume that the rest are failed to be rejected, and on the other hand, our residual is rejected. Means they are significant. The p-value is less than 10%, 5%, 1%. So in that case, if we reject the unit root for the residual, that means we contain a co-integrating relationship in the model, co-integrating relationship between the variables. All right, so assume that the variables are co-integrated. Yeah, so co-integrated means that they have a long-run relationship. They move together. Okay, so we close the co-integration test. Assume that we have a co-integrating model, a co-integrating variables. So we have a co-integrating variables. So since we have a co-integrating variables, we have to use the VECM, vector error correction modeling. Okay, so vector error correction modeling is a modified version of VAR. Yeah? As I mentioned before this, the difference between VECM and VAR is that VECM is used when the variables are co-integrated. VAR, on the other hand, is used when the variables are not co-integrated. Remember, all of these variables are non-stationary at level. Okay, so yeah, I'm sorry because we have Azan just now, so that is why I stopped from explaining for a few minutes. So if we can continue with the VAR, yep. we have time limitation, so let us finish with the VECM before we continue with time series. Maybe on the later part of, who knows, we may have, you know, additional session after this. In that time, I will show you the mixed stationarity, I mean the ARDL model, as well as the time, as well as the panel data analysis. So at this time, let me show you a bit on how to conduct the VECM model using Gretel. All right. So in order to conduct the VECM analysis using Gretel, assume that all of our variables, they are not stationary at level, and they are co-integrated, or these variables are co-integrated. Okay, if these variables are co-integrated, that means there is a long run relationship. Yeah, there is a long run relationship between the variables. So uh, in other words, uh, the co-integration, okay, the co-integration analysis will try to analyze whether these variables moves together in the long run or not. Yeah, whether they moves together in the long run or not. If they moves together, it suggests a certain relationship between the variables. So that's what it means by, you know, co-integration analysis. Yeah, that's what it means by co-integration analysis. Conducting analysis to identify whether variables moves together in the long run. When they moves together in the long run, that means there is some sort of relationship between the variables. Remember, in this workshop, I'm trying to use a simpler terminology so that all of us can understand. So of course, when you report the findings in your study, make sure that you are using a correct terminology. Pastikan kita menggunakan terminologi, terma-terma yang tepat apabila kita melaporkan hasil dapatan kajian kita. Dalam workshop ini, kita menggunakan terminologi yang lebih umum, namun ada terminologi yang bersifat lebih spesifik dan tepat, okay, dalam melaporkan hasil dapatan kajian kita. Okay, so now let us show you how to use the VECM, okay, in order to process your time series data. So just like VAR, click model, choose multivariate time series. Multivariate means you have multiple variables. Okay, you have multiple variables. You have more than one variables. Just like in our case, we have more than one variables. We have more than one independent variable. We have personal consumption. We have gross domestic investment. We have export. We have government purchases. So that is why we choose the multivariate time series. So now choose VECM. So remember, before this, I asked you to refer to the leg selection when you conduct your unit root test. Remember, before this, I asked you, when you conduct the unit root test, and then determine this, how many lags included. Okay, it will help you to determine what are the maximum lags included in your VECM model. But let us choose 4. Okay, say that we choose 4, just like the VER, where it is suggested we use lag 4 as the maximum lag in our VAR model. Let us use 4 in our VECM model as well. Remember, one of the way to determine the lag order is by conducting that unit root test. Of course, if you're using a different statistical software, there are methods that we can use. Sometimes some of the statistical software will determine the lag order automatically, so which is much more convenient. Unfortunately, that attribute, that function is not offered by Gretel, so we have to determine the lag order manually. In this case, let us choose 4 as well, just like our VAR model. Of course, we include all the endogenous variables, okay? And we don't have to include the exogenous variable. It depends on the number of, it depends on the model that you use. As I mentioned before this, kalau model yang kita gunakan memerlukan exogenous variable, kita letakkan exogenous variable. Kalau model yang kita gunakan tidak menggunakan exogenous variable, then you then have to include the exogenous variables. So I hope you guys can see the you know, what we are doing here, this Gretel statistical software used to analyze the VECM model. All right, so once you have this, you can choose. You have a number of options, as I mentioned before this. In my case, I choose unrestricted constant. Remember, it depends on you to justify what are the assumptions that you have, what are the assumptions that you include in the model. In our discussion, we assume that we have the unrestricted constant. Okay, then click OK. So here we have the results of our VECM model. Okay, so here we have the VECM model, and Gretel will show us the VECM system. Okay, where it is estimated based on the ML, maximum likelihood estimations. So there are a number of what we call as results that we can refer to. So in our VECM model, apart from looking into the significance of each of the independent variable in influencing the dependent variable, okay, so here we can see that GDP at lag 1 is significant in influencing the current level of GDP. Means the previous value of GDP is significant in influencing the current value of GDP. Same goes to the previous value of consumption are also significant. Okay, from lag 1 until lag 3 are also significant influencing the current GDP. And this, what we call as explanation, can be repeated for the other independent variables. So apart from looking into the statistical significance of each of the independent variable towards the dependent variable, another important information that you need to refer to in the VECM model is the error correction term. In this, it is denoted with the term EC1. So EC1, or error correction term, some people refer it as ECT. So the error correction term shows us the speed of adjustment of the independent variable when shocks happen in our independent variable. So in other words, the ECT term, if it is significant, it shows a significant relationship between GDP and the independent variable. It shows a significant relationship between GDP and our independent variable. All right. So that's the first thing that you need to refer to on the ECT. Another important information that you need to refer to the ECT is the sign of the ECT itself. The ECT itself supposed to be negative to show the speed of adjustment. Okay, to show the speed of adjustment. If it is non-negative or positive, then it doesn't show the speed of adjustment of the GDP when the independent variables moves. Okay, when the GDP, when the consumption, investment, export, and government expenditure moves, it doesn't show that GDP moves towards the equilibrium when the ECT term is positive. If it is negative, then it is preferred because it shows the speed of adjustment of the GDP when the independent variable, these changes. Yeah, just like, unfortunately, we don't have, because remember, we're supposed to VECM is conducted. Okay, the reason why I believe that the reason why we have a positive sign in the ECT is because this model is supposed to be non-co-integrated. So we're supposed to use VAR, but even though we forced to analyze the model based on VECM, that is why we have an improper, okay, an improper ECT result. Okay, so if this shows negative sign and it is significant, then it shows the significant correctness of the dependent variable when the independent variable moves. Yeah, so the ECT terms shows us the speed of adjustment. Yeah, For example, say that we have speed of adjustment. For example, for the sake of discussion, say that this is negative sign and say that our dependent variable is consumption. Yeah, and this shows a negative sign for the sake of discussion, and it is significant. So in that case, we can simply say that when our independent changes, when our independent variable changes, our consumption will moves back into the equilibrium in the long run. Remember, there is a long run relationship between dependent and the independent variable. When this independent variable changes, it causes the model to move away from the equilibrium. Okay, and when the model moves away from the equilibrium, the negative sign shows that the dependent variable will move back into the long run relationship, and this shows the speed of adjustment. 58 or 59% means, in this case, we have coefficient value of 59%. It means that 59% of the disequilibrium will be corrected in one period. Okay, will be corrected in one period of time. So if you're using an annual data, it will be corrected in 1 year. If you're using a quarterly data, it is corrected in a quarterly. If it is monthly data, it is corrected 59% in a month. If it is daily data, it is corrected 59% in a day, for example. So the speed of adjustment is shown by the coefficient of our ECT terms. So if you divide 1 to the coefficient term, you will show how many period of times required to fully correct the disequilibrium. In this case, it will require two period of time to correct the disequilibrium that happened due to the changes that existed in our dependent variable. So saya harap semua kita paham apa yang saya cuba maksudkan di sini, ya. ECT term bermaksud, okay, speed of adjustment, okay, kepantasan pelarasan pembuli ubah bersandar apabila pembuli ubah bebas berubah. Kerana pembuli ubah bebas dan pembuli ubah bersandar mempunyai hubungan signifikan dalam jangka masa panjang yang menunjukkan adanya equilibrium, adanya keseimbangan di antara pembuli ubah bebas dan pembuli ubah bersandar. Apabila pembuli ubah bebas berubah, ini menyebabkan keseimbangan, ini menyebabkan hubungan di antara pembuli ubah bebas dan pembuli ubah bersandar tidak berada pada keseimbangan. Significant that relationship dan koefisien yang negatif menunjukkan bahawa the independent variable will move back into the long run relationship. Okay, the significance and negative sign will shows the speed of adjustment of the model to move back into the long run relationship, to move back into the equilibrium. So that's among the things, but of course you have to test whether you have autocorrelation, heteroscedasticity, and normality in the residual as well or not. So you can conduct the autocorrelation. Of course, we can refer from here. The autocorrelation is approaching to, and it is negative autocorrelation. Okay, conduct the autocorrelation test. So here the autocorrelation is insignificant. That means you don't have the autocorrelation in the model. Another test is the heteroscedasticity test. Unfortunately, in Gretel, we only have the arc heteroscedasticity test. You can choose the number of lags. You can choose 2, 3, 4, but let us just choose 1. So we don't have arc heteroscedasticity existed in our model. And you can also choose or test the normality test. In this case, the Gretel uses the Dornick-Hansen test. Yeah, where this Dornick-Hansen test shows us a chi-square that when the p-value shows significance, that means we reject the hypothesis null of multivariate normality. In other words, if the p-value shows significance, it means that our multivariate residual, it means that our model contain non-normality, okay, or suffer from the problem of non-normal residual. Okay, I repeat, if the Donick-Hansen test is significant, that means we reject the hypothesis null of multivariate normal. In other words, if the Donick-Hansen test is significant, it means that we are suffering from a residual that is not normally distributed. So if I can repeat again the ECT term, which is the most important part in our VECM model, ECT term shows the speed of adjustment of the model to move back into the long run relationship. It's speed of adjustment of the model to move back into the long run relationship. And there are two important information that you need to look at into the ECT terms. One is the negative sign, and then the other one is the significance level. They need to be significant, they need to be negative sign, okay, to show the speed of adjustment of the model to move back into long run relationship. And the value of the coefficient shows the speed of the adjustment. It is preferred for the value of the coefficient to be less than 1, because if it is higher than 1 or higher than 0, sorry, if it is preferred, sorry, I repeat, it is preferred for the coefficient value to be negative and between -0 to -1. I repeat, -0 to less than -1. Yeah, because if it is -1 or higher, that means the model suffer from instability. The model is unstable. So it needs to be -0 to -1. -0 means 0.1, 0.2, 0.3, 0.4, 0.99, for example. Okay, so try to avoid a negative value that is higher than -1, okay, because it indicates instability. So that's it for the VECM. As I mentioned before this, we have time limitations, so I was unable to show you on how to process the data based on ARDL model and to process panel data analysis. Okay, so perhaps after this, I will try to record the methods to process the ARDL model and how we process the panel data analysis as well. Yeah, in the panel data analysis, we have various models. The most common will be to use fixed, random, and pooled OLS. Remember, this belongs to the static panel data analysis. There is another type of panel data analysis called dynamic panel data analysis, but that requires a more extensive discussion. Okay. So, do you have any questions so far? Before we end our discussion, I am sorry because it took us additional 40 minutes to conduct the session, and even though it took us 40 minutes, we did not manage to cover the entire time series data analysis and the panel data analysis. Yeah, I'm sorry for that one. And so if you have any question, you can simply ask me, you know, directly here, or you can post it in our chat room, if you can call it the chat room. And yeah, Puan Eli, adakah kita boleh tamatkan session ini sekarang ataupun tidak?
Dari dokter saja kita boleh tamatkan. Nanti kita bincang untuk the next workshop lah kali kan dokter? Sebab boleh.
Okay, boleh kalau macam. Okay, thank you Puan. So in that case, we try to end our discussion here. If I can briefly explain or briefly summarize what we have discussed so far. So far we have discussed about methods to analyze time series data based on least square methods, VECM and VER. Least square method is used when the data is stationary at level VECM is used when the data is non-stationary at level and the data is co-integrated, while VAR is used when the data is non-stationary at level and the data is not co-integrated. So in a least square method, we refer to the coefficients value, and there are a number of diagnostic tests that we have to go through: the normality test, heteroscedasticity test, and then the serial correlation test. While in the VECM model, among the important information that you need to look at will be the coefficients of the independent variables and then the coefficients of the error correction term, because the error correction term shows us the speed of adjustment of our model to move back into long run relationship when shocks happens in our independent variable. So the ECT terms need to be between -0 to -1. Okay, -0. Of course, 0 doesn't have any value, positive or negative, but I'm referring to -0.1, 0.111, for example, up to -1, because if it is higher than that, some even consider -1 as unstable. So try to avoid -1.00 as well for the VECM model. Of course, there are a number of tests that you can conduct. We have the serial correlation test, normality test, and then we have the heteroscedasticity test. Same goes to the VAR. Just like the ECM, you need to refer back to the coefficient value of all the independent variables, the coefficient value for all the lags, the significance level, and then the F statistic for the joint impact of the independent variable in their lags towards the dependent variable. And you also need to conduct certain diagnostic tests: normality, serial correlation, heteroscedasticity. So remember, as a disclaimer, if you can call it a disclaimer, I used basic terminology, yeah, so that it is easy for us to understand. But make sure that when you report your study later on, make sure that you use correct terminology, yeah, for the reporting. So I think yes, SPSS is used mainly for what you call as a survey-based study, just like Dr. Jaran said. Dr. Jarat said, yeah. I think that's all. Thank you very much, everyone, and stay safe. And I hope that you enjoy in conducting your research. Okay. Thank you very much.